right, go ahead.
Hello, this is Mark Stoddard, one of the co-chairs of the technical subcommittee. My colleague is Donovan Grimwood in Tennessee, and I'm proud to introduce Dr. Yangsheng Zhang. Hopefully I'm not mispronouncing his name terribly. He is with the Brulin Holding Company. He's going to share stories from his company's pursuit of VOC reduction. He works as the technical director. He manufactures and markets cleaning and maintenance products for a wide range of industries. Dr. Zhang's research team is involved in providing innovative solutions with persistent pursuit of reducing environmental impact and improving health safety. I got to know Dr. Zhang, I guess, through a connection I had with an electroplater. They service the medical aerospace industries, and they had been using trichloroethylene in a airless vacuum degreaser. And I think there had been a scare, an ongoing scare of trichloroethylene in the ground and groundwater, which kind of scared this company, although they had been looking for replacements and been having to deal with their customers and trying to maintain a certain standard of cleanliness, which is difficult, while looking for an alternative that would do the same kind of job, leaving the same kind of residue, none. And so my colleague with this company was able to work with Brulin, Dr. Zhang, to find an alternative, and I think it's being implemented maybe as we speak. So with that, I would like to turn it over to Dr. Zhang to start with his presentation. Thank you, Dr. Zhang.
All right, thank you, Mark. Thank you, Lynell.
Yeah, it's open now so that you can share.
All right. Is the screen share on?
Yes.
All right.
Just need to see the slideshow. There we go.
All right. Should I see the first slide? You're right, correct?
It's perfect.
Okay, great. Thanks, everybody. Thanks for the opportunity to speak over here. This is really an experience sharing, nothing more than that. We're very good in what we do, but we are not expert in everything. So what we know is a very small portion of a large knowledge base. So by no means this is just one drop of water in the vast ocean of the knowledge. So the topic I'm going to cover is a little bit about a Brulin Holding Company, previously known as Brulin, and I'll talk about replacement of a different type of solvent, the approaches we used. And I'm going to cover a little bit of the topics of green certification that's available out there, and some of the CARB compliant glycol ethers. And what's not over here is some of the new chemistries, as well as the equipment development on the equipment side. Brulin is we are stationed, we're headquartered in Indianapolis, Indiana, has been in business since 1935. We develop, manufacture, and market specialty cleaning products for institutional and industrial markets. Some of the market we serve are manufacturers of medical devices, automotive, aerospace, and space devices, and also cover schools, hospitals, building maintenance, commercial establishment, the cleaning needs or sanitation needs. The products for those markets include aqueous solvent degreasers, floor finishes, wax and paint removers, to general purpose cleaners and disinfectants. Our involvement in helping the industry migrating from the solvent cleaning process really started about 30 some years ago, 20 some years ago. So back in December 1997, one of the major manufacturers of solid rocket motor materials or the rocket boosters have approached to us and wanted to replace their trichloroethylene solvent in their refurbishing process. What we have offered is an aqueous chemistry as a replacement for their critical cleaning step in their refurbishing process of the post-flight space shuttle rocket motor. It's one of those, if you remember those space shuttle launches, you always, from the picture, you always see this space shuttle, and then under the wings, you have two solid rocket boosters. Those boosters are filled with fuels that's burned off during the launch, but the structural materials actually is dropped off into the ocean. It gets pulled out and gets refurbished to make the next rocket motor. That refurbishing process involves a large amount of cleanings to remove the bonding materials that was used to affix the fuels that is stuck inside the body. The replacement system was ended with an aqueous mild air cleaning degreaser, and was using a spray wash system that operates about 10% at 150 degree F, coupled with a two-stage rinse process. And to this date, they are still using this, even though the space shuttle program is ended. There are other space programs that uses solid rocket motors. The product is a blend of aqueous water and surfactants, a variety of different surfactants with builders, corrosion inhibitors, and defoamers to be operated with a spray wash tank. And as a profile, this product is also certified as a clean air solvent by the South Coast Air Quality Management District of Management. A little year or two later, we were approached by a different company that needs to replace Freon solvent in the cleaning of jet propulsion system hardwares. This is really about the oxygen kinds of oxygen transport system of the propulsion system. And the metal substrate tested was 7075 aluminum space, aerospace grade aluminum alloy, and stainless steel, titanium alloy, and the last one I think is the nickel alloy. And the soils that was able to remove are hydrocarbons and silicone vacuum lubricants. When they are looking for alternative to Freon, there are a set of criteria, and the most prominent criteria is the environmental criteria. Need to have no ozone depletion potential, as no global warming potential, low VOC, non-flammable. The solution we offered pretty much meet all of those environmental criteria, and they evaluated the product by stress corrosion, cleanliness, using visual inspection, UV inspection, water breaks, as well as non-volatile residual analysis. And again, The makeup is similar to the last one, is water, blends of surfactants, filters, and corrosion inhibitor. And it is also certified as a clean air solvent with a pH about 11.5 concentrate and about 11 and 10.5 when it's in use solution. Very recently, University of Dayton Research Institute has done a study with us and for us, comparing aqueous and degreaser and solvent degreaser side by side in the laboratory setting, trying to assess their ability to clean mil-spec all-purpose coating top coats after they are exposed to a set of artificial soils, which are made up by carbon blacks, 50-50% blend of carbon blacks, and mil-spec hydrolytic fluid. In this when they're testing this one, they used a procedure, a mil-spec procedure that basically measure the lightness of the panel, of the soil panel, which is the L asterisk of the coating before and after the exposure, after the cleaning. And the cleaning efficacy is expressed as a ratio of the change of the lightness after the cleaning to the change of the lightness before the cleaning. And this is expressed as a percentage value. So the percentage value is almost, you can think about as the percent of a recovery. 100% means that you recovered the soil, the panel completely in the measure of lightness of the panel. And the average result, that is on the four different, they measured the four different coatings of the same soil, and the result is very, sort of encouraging that aqueous alkaline degreaser at a 75-10% can achieve 70% of recovery of the cleanliness, compared with a blend of a solvent that is made of, it's an azeotropic solvent that is hydrofluoro ether and the 1,2-trans dichloroethylene, and which achieved 74%. I would consider they are pretty much equivalent. I don't know 6% is statistically significant, but at least this is showing that the two can perform equally well. And then, again, the recent sort of the effort we are in our pursuit to the VOC reduction and environmental safer solvent is working with electrospecs, who specializes in electroplating and passivation of different materials for medical, automotive, aerospace industries. They have approached to us in mid-2018, expressed the desire to replace their trichloroethylene in their vacuum degreasing process. So what we come up with is an azeotropic blend of this hydrofluoro ether with 1,2-trans dichloroethylene, and as a way to improve the trying to remove the hazardous air pollutant as attribute of their system, their process. After a small bench testing, they went through a pilot run, which involves about 110 batches of 4 different type of alloys and totaling 85,000 individual parts. The cleaning are done at 100 degree F and for roughly about 24 minutes, plus minus few minutes. Then they inspected the cleaning parts with the SCM for the cleanliness of the surface. Then after that, they run these pods through 18 different type of coating, plated coatings, and then do their normal inspection. And they only come back with 12 pods that need to be reworked. So, which is very encouraging and impressive too. So the other thing is that after this conversion, Electrospec will, as a company, actually will not going to be a hazardous waste generator. They basically removed their last material that is, made them a hazardous waste generator. So they are very, very excited about that. As we speak, I was just there today. Their system, their production system was running today, and actually the first run started sometimes last week. So they're in their second week of production of the solvent. And here is some images that they took for us on the ESEM pictures. From the left to right, you have soiled pods, then compare with the cleaned pods with the TCE and the clean pods with the trans DCE as how they appear. And then they also went on for EDAX analysis, which is elemental analysis on the surface. They traced to the sulfur content of the soil as an indicator whether the soil is being removed from the surface or not. This is an image of the plated pods after those cleaned. Then they put these pods through the plating, and they did a two lot A and lot B, and then also in an EDAX image of that coated surface. And the final inspection is their standard inspection in terms of a standard thickness, tab testing, cross-testing, bake testing, as well as a visual. So, I think that those are the effort or the experiences we've continued to have in the pursuit of this environmental safer solvents. In general, I think we are, I can say that this is probably the general trend of the industry. May not exactly follow this order, but I think we are generally moving from left to the right. In the 20, 30 years ago, the chlorofluorocarbons are the predominant material of choice for degreasing cleanings. And then after the Clean Air Act, or more specifically, the Montreal Protocol goes into effect, and the world and the country made a lot of effort to move away from the CFCs. And as a result of that, I think the methane trichloroethylene and probyl bromide and the chloroethylene becomes the predominant replacement, because these has pretty much no ozone depletion potentials. Nonetheless, they're not perfect. More and more so, these becomes a headache in terms of hazardous air pollutant. So again, the next things, at least we are looking at, is the next class of chemicals: hydrofluorocarbons, hydrofluoroether, trans dichloroethylene. That class of materials. But they are better than the TCEs and TCAs in terms of HAPS compliant, or in terms of a HAPS measure. They are not HAPS. However, they are not perfect. I would still consider they are transitional solutions, because while it is true they're not ozone depleting potential, they are not HAPS, but some of them are still greenhouse gas VOC, like trans-dichloroethylene is a VOC, even though it doesn't have ozone depletion, even though it's not a HAB. So is also most of these suffer some level of global warming potential. So it's not really perfect yet. So what we see and what we are exploring next is the class called hydrofluoroolefins, which, as a class, there are more choices of materials that have zero ozone depletion, less than like 1, maybe sometimes 0.01 global warming potential. They are not greenhouse VOC. They are not HABs. So I think that's pretty much what we are working on next. And with the electrospec, we are also already introducing our next generation solvent degreaser that is in the class of hydrofluoroolefins. However, with all these encouraging developments, as a scientist, we always like to, be fair with the science and just keep a kind of a cool head. The challenges still remain. We're really haven't really get to a point that the solution is ready to be there yet. There's still a lot of work ahead of us. Dr. Darren Williams from Sam Houston State University, his research group did a very extensive studies as an effort to find azeotropic blend that can be a drop-in, sorry for the misspelling, drop-in for TCE and NPB replacement without undesirable environmental, occupational, and safety health properties. When I say that, he was looking for, his aim is looking for an azeotropic blend that can have properties, like desirable properties across all these 5 attributes, including the flash point. So that was his kind of constraint. And then I believe the study went few years. They went through, they used Hansen solubility parameters and environmental and safety health data database and screened and analyzed over 22,000 substances. What they found was that they didn't find any single fluid that actually can meet these selection criteria, but able to clean the grease or solder flux residue as good as TCE and NPB. So that report was published in December 2016. So in other words, we are making better in terms of getting rid of undesirable features, like there's no problem picking choices in terms of zero ozone depletion potential. You have a lot of choices over there. So, but we're pushing the envelope of global warming potential reduction. But when it comes to VOC and flashpoint, that is still going to be a challenge. If you have to meet these 2 requirements, and per Dr. Williams' conclusion, there isn't none found yet. I don't know how many people are familiar with the Clean Air Solvent certificate, so I thought I'd just throw this slide over here just for reference. This is a certificate that offered by South Coast Air Quality District of Management. So a certified solvent would mean that you have these attributes. And since we're dealing with institutional cleaning products, in addition to industrial products, in the past about 10 years ago, maybe 12 years ago, or starting 12 years back, we are starting to work with several organizations to get our product certified as a green products. And there are, notably, there are about 3 organizations that are actively and doing better with a significant scale. Green Seal is one organization. EcoLogo is one organization. The EPA has a program of their own, used to be called a Design for the Environment. Now they are renamed, they're called a Safer Choice. What all these organizations are doing is that they are providing a criteria-based way of judging how green your product is, which include ecotoxicity evaluation, human toxicity evaluation, also has a requirement of a cleaning performance. And the green criteria also extend to the packaging, labeling, and the training requirements. And to get product certified, the manufacturer of the product must have gone through an on-site audit by this organization, and as well as subject to regular periodic monitoring inspections. And the certification covers a fairly wide range of products, going from general purpose cleaner, glass cleaner, bathroom cleaner, etc., and floor finishes and wax removers. And then with related requirements to this topic is that they apply the most stringent VOC limit. In this case, they use the California VOC limit as the requirement. They require no ozone depletion. They do not allow ozone depletion compound, global warming compound, and HAP compounds. So those are the effort. In those kinds of effort, initiative trying to get green certification, we basically are looking for, the alternative we're looking for or looking to use can generally fall into this kind of a class called a CARB compliant glycol ethers. Glycol ethers, because they are due to their water solubility, a good water solubility, they are a common choice, a general choice is used in floor finishes, wax removers, and general purpose cleaners, and they are very good to use. So in our way to be VOC compliant, our approach is to use the CARB compliant glycol ethers. CARB compliant usually means the list on the right-hand side, these are classified as low VOC exempt, low vapor pressure exempt VOC choices. So we are migrating from the left-hand list, which are VOC, to the right list, and we have a lot of good success in that area. That we can have product that doesn't really need to use the EBs, the butyl salicyls, and methyl carbitol groups anymore. And also, there are new chemistry always coming up, and the first one may not be as relevant. We are really heavy in using biodegradable surfactants, 2 classes. That is very heavily sort of selected, linear alcohol ethoxylates, and then alkyl polyglucosides, commonly known as the sugar surfactants. They perform very well as a replacement of NPE or APE surfactants, even though those are not related to the VOC. Now, there are, in the last probably 2-3 years, there are biorenewable sourced solvents that came onto the market that, has really matured, that we've used a few of them that in a couple of examples, places that found really good success. They're sourced from plant seeds, algae, and other otherwise, disposed plants. And then some example is from this company, Elevance Clean 1000, that is have a pretty good potent solvency in it. And they are not VOC, and they don't have flash point. Equipment side, also, you have, when it comes to solvent degreaser, one of the more open setups is the open top solvent degreaser. And then a better setups which gives you better control, more control, is the vacuum solvent degreaser, which is enclosed system. It's sometimes called airless vacuum solvent degreaser. You don't have your process does not expose to open air, so you have very, very minimal solvent loss to the atmosphere. And then there's something new that we came across recently. And this process probably is not new, but it's picking up some sort of popularity. Is they call this company called them vacuum cycling nucleation, which is a pretty novel concept. It's a step up from the vacuum solvent degreaser. It's still clean. You still clean in the vacuum chamber, but instead of introducing ultrasound as a source of agitation, they actually cycle the pressure in the vacuum chamber, and they pull the vacuum down to really boil the solvent in the chamber. And then when they boil, they provide this scrubbing effort. The bubbling effect provides this scrubbing effort on the surface liquid interface. And then this, they claim that it works really nicely because you don't have the limitation of the ultrasound, which is a little bit direction orientation dependent. There can be some blind angles or blind spots in the ultrasonic field that you don't get the same energy as the surface that directly exposed to the ultrasonic transducer. But with the cycling nucleation, because the vacuum is universal, has nothing to do with the geometry or the angle, that in theory, you can have the scrubbing action happen in all different angles or surfaces, even how to get to like inside the tube. So that's pretty interesting. That pretty much covers what I have to say. That I'm open for any questions or anything.
You have any questions? So everybody, here's a chance to ask questions. Anything you want to know. There's no dumb question.
I would just remind folks I muted people during the discussion, so if you do have a question, you need to unmute. Sorry about that, but there was a lot of background noise and we're recording. Thank you.
And Linnell, I thank you for that.
No problem.
Well, Dr. Zhang, I'm just curious. There was a push for, I guess, people to get out of using nonylphenol ethoxylates.
Yes.
Do you get a lot of requests for alternatives? And I know the alcohol ethoxylates may not be equivalent. Do you have to do anything extra to make them comparable as far as their cleaning efficacy?
Actually, the nonylphenol ethoxylates push has been happening since 2012. I think the kinds of nationwide, my understanding is the nationwide action is going to probably be 2020, meaning that a lot more states, if not every state, is going to adapt to the ban of NPE. So yes, we have actually started working on those since 2008. Since 2008. There are a lot of pushes, more and more so, that it becomes, right now it becomes like when we work with the customers, most of them, I would say 80% of them kind of take it for granted that we don't bring products with NP to them. It's almost like in the beginning of the conversation, like, you know, anything you do you have an NPE? On top of that, especially in the industrial products groups, REACH compliant is really big right now, and so big that when it's a part of our product development, we don't develop any new industrial product without conforming to a REACH requirement, without conforming to NPE requirement. But to answer your question about the linear alcohol ethoxylates and APG, based on what we've seen, we really don't have a lot of trouble switching. There's plenty of choices out there that will perform equally or better. I think APG actually plays better in many cases. There are actually soils we'll come across that it does not do as good. I'm not very familiar with who actually using those soils. I can tell you that from the basic chemistry point of view, because the APE has phenol ring in it or benzene ring in this. Any soils that is a derivative of phenol or benzene, you have a chance to see the differences. But I don't know the popularities of those soils, just pure from academic point of view. But normal cutting fluid, even you know, those rebuild and overhaul shops, we have NPE alternatives that basically they told us they couldn't really see much differences. They couldn't tell if we actually done some blind testing with the clients that they couldn't tell the differences much.
Now, Dr. Zhang, do you ever get any, you deal with a lot of maybe clients who are maybe metal fabricators or metal finishers, but they also have to deal with the federal government, like the FDA or the aerospace, whoever oversees that. Right. Do you have to try to also win over the support of, say, like the FDA when you're bringing in a new product that's supposed to be greener?
We don't really have FDA. We don't have those type of requests from the government side. But in terms of metal industry, but the reach is as much as they will require. But with the VOC limitations in different state at the different state level, with the NPE bans that at the federal level, I think that just becomes a must-have attributes when we introduce new products for them. Now, on the other hand, on the institutional side of it, there are actually mandates when we work with school systems and government entities. They will not accept non-green certified products. They have to have green certified, whether it's a DFE, I always call them DFE, but EPA Safer Choice certified, Eco Local certified, or Green Seal certified. They have to have those. More so with the government bids, state government, contract bids. So that is like there's no question. You take for granted that they have to have the Green's Choice. I don't know if you're familiar with another green certification, which is certify the building maintenance. There are, I think they call it LEED. I forgot what the acronym stands for, LEED. Sometimes you go to some buildings, brand new buildings, they have signs of brown or gold, LEED certified. That's a green certification that covers a wide variety of requirements, from energy consumptions to others, but a portion of it is the cleaning product they use on the facility has to be green certified. And that regulates the service group that does the janitorial services of the building. So in those cases, you have to, it's a mandatory. There's it's non-negotiable.
Dr. Zhang, changing our topic a little. There's been a lot of news regarding perfluorinated carbons, PFCs. Mm-hmm. Some of them are used as surfactants.
Right.
And honestly, I don't even know. My familiarity is the metal industry, the electroplating industry, and the use of surfactants as part of electroplating baths.
Right.
And you may not necessarily supply that type of material, but do you see any changes or alternatives for the use of perfluorinated carbons as far as?
Yeah. We actually use that in our products. The fluorinated surfactants are used in places where you need leveling or reduce the surface tension. That's what they are very good at it. So in our floor finishes, we, just like a paint industry, I imagine any paint industry or like a floor finish, which is a type of coating on the floor, you apply that, you need that coating to flow out before it dries, so it forms out extremely smooth surface to give you the shine. So in that type of formulation, we do need leveling agent that many of them are fluorinated surfactants. So there are a lot of alternatives that is really working very well. I think the general way to judge those is the carbon length. I think the earlier ones before the regulation, the fluorocarbon surfactants are based on C8 or higher, like C8 or C10 gen length surfactants. Then those are the more, the consensus obviously is the persistent bioaccumulation. They never go away. They stay in the environment and then end up in your body, in the plant, and in the water, everywhere. So the development has, they've already gone 2 phases of development. We've moved from C8 to C6. That was probably 3-4 years ago, maybe I should say 5 years ago. And then the industry actually has moved down to C4 fluorosurfactants, and they are also perform equally well. So all of our fluorosurfactants for finishes are on C4 carbon length fluorosurfactants, and they work, equally well.
I don't want to hog the conversation. Someone's got to have another question besides me.
We had something in the group chat, Mark. Someone wrote, is there any real way for companies to compare chemicals that you know of, depending on their process, ? We have had a lot of our vapor degreasers goes to NPB, and now to know that it may be a worse carcinogen than TCE, that puts companies in a strange spot. You have any thoughts on that, Dr. Zhang?
Yeah, I probably didn't understand the question exactly. I heard a description, but what is the question exactly?
I think, is there a way for companies to really compare these chemicals, side by side, to make these determinations? And is it process dependent?
Yeah, for the purpose of the ESH profile, or for the purpose of performance, or both?
I think it could be both. They gave an example of vapor degreasers using NPB, and that's as bad as, or worse maybe than TCE, is what the comment said. So,
got you. Let me answer this in two different ways. Okay. There are companies out there, there are organizations out there that actually does evaluate the performance of these chemicals in the laboratory setting in the unbiased way. I don't remember the full name, but the acronym of this group is called TURI. It is a group in Massachusetts that is associated with the Massachusetts EPA government, but this is a research lab. They actually do a great deal of product evaluation, for services and for researchers. That's one of the organizations I know that their mission, their scope of their operation is product evaluation. So if you are interested, you can reach out to them and ask those questions, or have products evaluated, or maybe just discuss with them. So this is for the performance side of it. From environmental side of it, I think many of them, I would think that many of them really is data-based. We go to government and state level website to pull the data out of it as a way to judge what's there, whether it's the ozone depletion rating, what is the GP, whether it's the global warming ratings. For example, if a product is a VOC or not, we always go to this California Consumer Product VOC regulation because we consider that is the most stringent requirement, and they have very well defined about what defines as a VOC, and we usually look that up as a confirmation to say if this is considered a VOC or not. I don't know if that answers the question or not.
Hi, my name is Donna Twickler. I'm with US EPA. I just wanted to mention as a follow-up that the TURI is Toxic Use Reduction Institute, and they, I believe, look also at health effects of chemicals in addition to efficacy. And then the other one is Safer Choice, which looks at both also.
Right. So, and speaking of that, thank you. And speaking of that, the Safer Choice has a website. I believe it's called a green ingredient or green. I don't even know how to say, they concatenated two words, the green ingredient, a website. They are making a list of all the chemicals that they have reviewed and deemed acceptable by their green criteria. And then we as a formulator, we usually go there very frequent. Just before we start, we just look at this. If a product is that registered or on that list, then chances are it's a safer to use.
I've put some links out on the group chat just in case people are wondering or want to find information.
Dr. Zhang, I know one of the issues related to dry cleaners, and I think they might have tried to make the switch from perchloroethylene to N-propyl bromide. I don't recall if that was the one that was a drop-in, because a drop-in replacement is a lot cheaper than having to buy new equipment in order to use a different material in order to clean with. So as far as a vapor degreaser, do you find it's a challenge to find maybe solvents that are cleaner or greener, but that can potentially be a drop-in for the same piece of equipment you're using with TCE?
It can be. It depends on the product you're switching to. If you're switching from TCE to, say, 1,2-trans-dichloroethylene, the switch over is not difficult. You do have to change the rubber seals. The rubber seals that is compatible with the TCE, the Vitons, the Teflon, is not always compatible with the trans-dichloroethylene. But you don't have to retrofit the unit if it's a vacuum degreaser. That's what I'm talking about. If the vacuum,
right, yeah,
you don't have to retrofit it a lot. With one potential, exception, the TCE, the boiling temperature is about 220 Fahrenheit, if I remember correctly, and the blend, I use our product example, which is a blend of HFE and the trans-dichloroethylene. That the boiling temperature range is about 94 Fahrenheit, or depending on how you formulate the azeotrope blend, you'll be in that range, in the low 100 range. That when you get down to 94, you may end up with an equipment that cannot regulate below lower than that. So that could be in the challenging zone. Now, our next generation, the hydrofluoroolefin, is indeed becomes a real challenge because the boiling point is even lower. So that may require more retrofitting of the unit. I do know that most of the open top unit will actually be more difficult to retrofit than the vacuum one within this 100 to 200 Fahrenheit range. But if you going below 100, it will become quite challenged. Yes, indeed. That's an unfortunate situation. Yes. But the electrospec, they had a airless vacuum system. They actually didn't have to change a lot. All they did is change the rubber seals.
Right, because the material would dissolve the seals and make them ineffective.
Correct. So, and then the flash point, not the flash point, I keep saying the flash point, the boiling point of our product is 94 degree F, which is just above where they feel comfortable. Their control unit cannot control anything lower than 77 Fahrenheit. So 95 gives them about 10, 15 degrees cushion. So they're okay with that.
Anyone else? Because we're closing in on the end. And again, I want to thank Dr. Zhang for his wealth of knowledge and his willingness to share this knowledge with our community. Also, I want to make people aware we have next call is March 19th. I wasn't able to attend or participate